Good day, viewers. If you're writing this year's post-utme exam and you're finding chemistry calculation difficult for you, this video is for you. Now, here we have the question: what mass of a divalent metal M, atomic mass, equals 40 would react with excess hydrochloric acid to liberate 224 cm3 of dry hydrogen gas measured at STP. Now, the word STP means standard temperature and pressure, and they gave us the molar volume to be 22.4 dm3. Now, how to solve this question? The first thing is your solution, and you bring out your parameters. Now, how to do that? Let's read the question again. They said, what mass? That means they are asking you to calculate for what? The mass. So from here, the mass is not what? Given. And let's read again. What mass of a divalent metal M with atomic mass equals 40? So here I have what? The atomic mass, which is the same thing as what? Mass number is equal to 40. Would react with excess hydrochloric acid to liberate 224 cm3. 224 cm3. Now look at this. This is what? Volume. cm3 is what? Volume. So we are going to have the volume to be 224 cm3. Dry hydrogen gas measured at STP, and they gave us the molar volume to be 22.4 dm3. So we have the molar volume to be 22.4 dm3. Okay, now the first thing, let's think about the formulas that contain mass. The first one, I have concentration is equal to mass all over what? Molar mass times 1000 all over volume. This is what? The first formula. We have another formula that says number of mole equals to mass all over molar mass. Now, let's look at the parameters and check which of these is what given to suit this question, or we can use to what? Solve this question. Now, we have mass, mass number. Now, the mass number can also be known as what? The molar mass. So instead of me to use mass number, so I can say the molar mass. So the molar mass, also the mass number for this question. Why are we using mass number? If you check, this is not a compound, this is what? An element. And they give us what? The atomic what? Mass. And for me to get the mass number of an element, or the molar mass of a compound, is the sum of what? The mass number of what? Different what? Elements in that compound. So but now we are talking about what? A single what? Element. So the mass number is also known as what? The molar mass. Now, having known that, they gave us volume and what? Molar volume. Let's check at this question. Volume is given here, volume is given here. The molar mass is given, mass number is also here, but we don't have what? Concentration. So we cannot look for these two at the same time. We cannot look for what? Mass and what? Concentration. Now let's check. Can we get, which other formula can we use? They gave us volume and they gave us what? Molar volume. Now there is also a formula that says that number of mole is equal to what? Volume all over what? Molar what? Volume. Now here in this formula, we can use this one, mass all over what? Molar mass, because we can look for what? The number of mole. How can we look for the number of mole? They gave us what? Volume all over what? Molar volume. So we can substitute the volume and the molar volume to get what? The number of mole. Then we can come here to calculate for what? The mass. So let's try it out. So from here, our number of mole is equal to, the volume is what? 224 cm3. Now here, the molar volume is in dm3, and they gave us our units from the question in what? cm cube. So we must solve in what? Cm cube. So we are going to convert this dm cube to what? Cm cube by multiplying by what? 1000. So from here I'll have 22.4 dm cube. So if I want to convert, I will multiply by what? 1000. So I'll have 22.4 times what? 1000. I'm going to have 22,400. So I'm going to substitute it here. I'm going to have 22,400. Now if I divide this is now in cm cube. Cm cube will cancel what? Cm cube. My number of mole will be 0.001. Now since I've gotten my number of mole, remember they didn't ask us to what? Calculate for what? Number of mole. But we need the number of mole here so that we can get what? The mass. So since I've gotten the number of mole, I can substitute it to the first formula and calculate for what? The mass. So let's check it out. So from here, I can say my number of mole is equal to what? The mass all over what? The molar mass. So my number of mole, I will substitute it. I have 0.01 equal to my mass. The mass is what? Is not given, and our molar mass is what? 40, right? Which is also known as our atomic what? Mass. So I'm going to have my mass equal to what? 40. So from here, I will cross multiply. I'll divide it by 1, and I'll cross multiply. I'll have 1 times n equal to 0.01 times 40. So I'll have m is equal to 0.4 grams. Here is our answer. Now, there is another method to solve this question. Now, since I know that there is another formula that says molar volume or mass all over molar mass is equal to volume all over what? Molar volume. Now, how do I get this? From here, I knew that number of mole is equal to what? Mass all over what? Molar mass, and number of mole is equal to volume all over what? Molar volume. So from here I can what? Substitute. Anywhere I see number of mole, I can substitute what? Mass all over what? Molar mass. So from here I'm going to have mass all over what? Molar mass equals to volume all over what? Molar volume. Now let's check if it's going to work. Let's substitute all the parameters given into what? This formula. So the mass is not what? Given, and our molar mass is what? Tell me. Our molar mass is what? 40. So I'll have 40 equal to, what is our volume? 224. So I have 224 divided by our molar volume. It was in dm cube, but we converted to what? Cm cube. So I'm going to have 22,400. So from here I will cross multiply. Here I'm going to have 22,400 times m equal to 40 times 224 cm cube. So if I multiply this, I'll have 22,400 m equal to 8,000. If I multiply this, I'll have 8,960. Divide both sides. We want to make m subject of formula, so divide both sides by 22,400. This will cancel out this. Here I'm going to have also 22,400. So my m is going to be, this will cancel out this. I'm going to have 0.4 gram. So if we use this formula, we still have the same answer. If we use this other method, we still have what? The same answer. If you find this video helpful, do well to what? Subscribe, and if you have any question, you can put it down on the comment section. Thank you.